Okay, this is page 10 of the synchronization notes. And this is our mutex example. And you can see up by the top here that we have an OS mutex ID type, and I've called it MUT for mutex. And mutexes are used to protect shared data, so we need shared data. And so I've made boolean b a global variable and initialized it to true. And you'll note on the previous page, the semaphore was a global as well, so that both tasks could share it. You could pass it in as a parameter, I guess, but that gets a little more messy. So this was simpler. Let's look at the main now. So we initialize the kernel, and there's an OS mutex new statement here, and we assign the result to MUT. But here we're passing it an attribute structure, and the attribute structure I define here. So I am using a designated initializer. This attribute type is really a struct, and I want to set the attribute bits. The other bits will default to 0, which the way that they've designed the type is 0 is the default value for those the other fields in this struct. So I want to set the attribute bits, and here I'm using 2 bit flags. So OS mutex priority inherit. So it's using priority inheritance, which we're going to talk about shortly, and it's also, that is ORed with this bit flag, OS mutex robust. Robust means that if a thread that's holding the mutex is deleted, then it automatically releases the mutex. So that's an example of initializing an operating system type with the non-default attributes. And create 2 threads as before, and again check that the mutex in the 2 threads initialized okay, so none of them are null, and we start the kernel. So let's go up to thread 1 up here. So the first thing I did is I set the priority, and I'm for this thread of T1, and setting it to priority high. And this thread is just going to run periodically, so you can see that there is a delay here. And this time I've divided by the tick frequency by 20, just an arbitrary value. And then it wants to read B. So there's the read of B. I've just circled it in that print statement. So if B is true, this is the conditional operator here, the question mark. So if B is true, then it's going to select the first statement here, which is a string, says true, and that's what will go into S. Otherwise, it will select false, and that will go into S. So it's just going to print out what's the current value of B. But that's a shared variable, shared with another thread, and so it's sandwiched between a mutex acquire and a mutex release. And so for the acquire, you pass it the mutex ID, and also wait forever. And to release it, you just need the mutex ID. You'll notice that I've used curly braces here. They aren't necessary. It's just used to denote or emphasize that any statements that are between those brace brackets are sandwiched by the OS mutex acquire and OS mutex release. So it just makes that critical section stand out. So this is a critical section. Okay, let's go to the second thread. So it does not change its priority, so it's OS priority normal, and it acquires the mutex, it's the same pattern, and it releases when it's done, and this is its critical section here. So critical sections don't have to do the same thing. They share the same data though, in this case B. So B is being assigned to, first we read it, we complement it, and then we assign it back to B. And once in a while, thread 1, since it's a higher priority, when its delay ends, it's going to read the mutex, it's going to acquire the mutex, read B, print something, and return. And the timing of these two is not really synchronized or coordinated. So I ran this, and it printed out false, true, false, 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 and it's just it's a matter of timing. So it could have printed out all trues, all falses, could have alternated. You never know. So that's our mutex example.